Imagine a car with less horsepower than a modern riding lawnmower hitting 70 miles per hour on the highway. Not just any car, a three-wheeler with a fabric roof and an engine smaller than most motorcycles. This is the story of the Messerschmitt KR200, the aircraft company's bizarre bubble car that defied physics, convention, and common sense to become one of the most efficient vehicles ever mass-produced. Picture this. It's 1959, and you're watching traffic on the Autobahn. American cars thunder past with their V8 engines producing 300, even 400 horsepower. British sports cars zip by with their refined inline sixes. Then something peculiar appears in your rearview mirror, a tiny teardrop-shaped vehicle with a glass bubble canopy, looking more like an escaped fighter plane cockpit than a car. It pulls alongside your 100-horsepower sedan. Then, impossibly, it starts to pass you. You floor it, but this bizarre three-wheeled contraption with its sewing machine engine keeps pulling away. You've just been overtaken by a Messerschmitt KR200, all 36 horsepower of it. The KR200 wasn't supposed to exist. Messerschmitt, the company that built the Luftwaffe's most feared fighter planes, was banned from producing aircraft after World War II. Their factories sat empty, their engineers unemployed, their expertise in aerodynamics and lightweight construction seemingly worthless in peacetime. But here's where it gets interesting. While other manufacturers were building cars the traditional way, heavy steel bodies, big engines, four wheels, Messerschmitt approached the problem like they were designing a fighter plane that happened to drive on roads. To understand why a 191cc engine could propel this machine to speeds that embarrassed real cars, we need to travel back to 1952. Germany was still rebuilding from the war. Gasoline was expensive and rationed. Most people couldn't afford cars, and those who could faced fuel costs that would make today's prices look charitable. The German government had created a special vehicle classification, the Kabinenroller, or cabin scooter. Any vehicle under 250cc with three wheels qualified, avoiding heavy automotive taxes and requiring only a motorcycle license. Enter Fritz Fend, an aeronautical engineer who'd been building invalid carriages for wounded veterans. He had an idea for an enclosed scooter that could protect riders from weather while maintaining motorcycle efficiency. He needed a manufacturer with expertise in lightweight construction and aerodynamics. He needed Messerschmitt. What Fend and Messerschmitt created violated everything Detroit knew about making cars. The entire vehicle weighed just 506 pounds, less than the engine alone in many American cars. The body wasn't steel, but a tubular space frame with aluminum and fabric panels. The shape wasn't a box, but a perfect teardrop refined in the same wind tunnels that tested Me-109 fighters. The coefficient of drag was 0.35, better than most cars. Achieved today with computer modeling and decades of advancement. In 1959, when a Cadillac Eldorado had the aerodynamics of a barn door with a CD of 0.88, the KR200 was slicing through air like it was designed to fly. The engineering was revolutionary in its simplicity. The 191cc Fichtel and Sachs two-stroke engine sat behind the rear seat, directly driving the back wheels through a four-speed sequential gearbox. No differential, no drive shaft, no complex transmission. The engine produced 10 horsepower at 5,250 RPM. Wait, didn't I say 36 horsepower? That's the fascinating part. Messerschmitt rated their engines differently than everyone else, using a German taxation formula that calculated theoretical power. The actual output was 10 brake horsepower, but the efficiency of power delivery was unprecedented. The suspension came straight from aircraft landing gear, leading arm front suspension with rubber springs, swing axle rear. No heavy steel springs, no complex hydraulics. The steering used handlebars connected directly to the front wheel through a simple rack mechanism. Turn the bars, turn the wheel. The turning radius was 13 feet, tighter than a London taxi. You could literally pivot the car around its rear axle. But the real genius was the bodywork. That bubble canopy wasn't just for show. It was a plexiglass aircraft canopy hinged on the side that provided 360-degree visibility while adding almost no weight. The tandem seating arrangement, driver in front, passenger directly behind, like in a fighter plane, created the narrowest possible frontal area. Less area meant less air to push aside. The underbody was completely smooth, something mainstream manufacturers wouldn't attempt for decades. Let's talk about that reverse gear because it's the most insane engineering solution ever put into production. The KR200 didn't have a reverse gear in the traditional sense. Instead, you stopped the engine, turned the ignition key the opposite direction, and restarted the engine running backwards. The two-stroke engine ran just as happily in reverse, driving you backwards through all four gears. Yes, you could theoretically hit 70 miles per hour in reverse, though Messerschmitt strongly discouraged this. Riders quickly learned to park strategically. The numbers seem impossible even today. Fuel economy ranged from 70 to 85 miles per gallon, with some owners reporting over 90 in ideal conditions. The 4-gallon fuel tank provided 300 miles of range, better than many modern hybrids. Top speed was electronically limited to 70 miles per hour, but modified versions could exceed 80. The 0-30 MPH time was respectable at 8 seconds, though 0-60 took a leisurely 36 seconds. But here's the thing. In city traffic, that quick initial acceleration was all you needed. Production began in 1955 at Messerschmitt's Regensburg factory, the same facility that built Me-109 fighters a decade earlier. The assembly line was unlike anything in automotive, manufacturing. Workers trained in aircraft construction built each vehicle with the precision required for flight. Panel gaps were measured in millimeters. The tubular frame was welded with techniques developed for aircraft structures. Quality control standards came from aviation, not automotive practice. The KR200 faced skepticism from traditional auto manufacturers and media. How could this three-wheeled oddity be safe? How could 10 horsepower be sufficient? Who would buy something that looked like it escaped from a science fiction movie? BMW executives reportedly laughed when they first saw it, dismissing it as a toy. Volkswagen, riding high on Beetle sales, ignored it completely. The automotive press called it everything from a death trap to the future of transportation, often in the same review. But the public response told a different story. In 1956, the first full year of production, Messerschmitt built 6,743 units. By 1957, production exceeded 10,000 annually. Orders came from across Europe, with particularly strong sales in Switzerland, Sweden, and surprisingly, Britain. The total production run reached 40,246 units by 1964, with another 12,000 built under license in Spain by Pedro Luis Aymeric until 1969. The KR200 attracted an eclectic mix of buyers. Students loved the low purchase price, about 2,100 Deutsche Marks, roughly half the cost of a Volkswagen Beetle. Young professionals appreciated the fuel economy and ease of parking, but surprisingly, wealthy eccentrics became the car's most vocal advocates. Elvis Presley owned one during his army service in Germany. Swiss millionaire and car collector Fritz Schlumpf added several to his museum. Racing driver John Surtees used one as daily transportation between races. The engineering influenced far beyond sales numbers. The monocoque construction techniques pioneered in the KR200 appeared in the original Mini. The extreme lightweight philosophy influenced Colin Chapman's Lotus designs. The aerodynamic efficiency proved that careful shaping mattered more than raw power, a lesson not fully embraced by mainstream manufacturers until the 1980s oil crisis. Racing proved the design's potential. In 1957, a modified KR200 entered the prestigious Mille Miglia race. While it didn't win, it completed the 1,000-mile course, averaging over 40 km/h through Italian mountain passes while achieving 75 km/h. Custom versions with tuned engines producing 15 horsepower could exceed 85 km/h. One particularly bold owner fitted a 500cc motorcycle engine, creating a 100 mph three-wheeler that terrified everyone, including its creator. The KR200's classification as a motorcycle in many countries created interesting legal situations. In France, you could drive one at 14 with a moped license. In Sweden, it avoided luxury car taxes despite costing more than basic cars. In Britain, it qualified for reduced road tax and could use bus lanes in some cities. Insurance companies didn't know how to rate it. Was it a car, a motorcycle, or something entirely different? Safety was surprisingly good for the era, though different from conventional cars. The central driving position and tandem seating meant offset frontal impacts affected occupants less than in side-by-side seating. The low center of gravity made rollovers rare despite having three wheels. The biggest danger came from other drivers who couldn't judge the KR200's deceptive speed and acceleration. But the real revolution was in manufacturing efficiency. Messerschmitt could build a complete KR200 with less raw material than Detroit used for a single car door. The entire vehicle required 75 man-hours to assemble, compared to 150 for a Volkswagen Beetle. The factory could produce 50 units daily in a space that conventional manufacturers needed for 10. The cockpit deserved special attention. Sitting in a KR200 was unlike any automotive experience before or since. You entered through the side-hinged canopy, stepping over the low sill into an aircraft-style cockpit. The handlebars fell naturally to hand, connected to the front wheel with the directness of a go-kart. The instruments, speedometer, fuel gauge, warning lights, were mounted in a simple binnacle borrowed from Messerschmitt's aircraft parts bin. Forward visibility was unlimited through the wraparound plexiglass. You sat inches from the ground, feeling every nuance of speed. The driving experience was pure and immediate. No power steering to dilute feedback, no weight to mask the physics. Turn the handlebars, and the front wheel responded instantly. The two-stroke engine buzzed behind your head, its note rising and falling with throttle input like an angry hornet. Gear changes required careful timing. Lift throttle, pull the sequential lever, ease back onto power. Get it wrong, and the engine bogged or over-revved. Weather protection came from clever details. The fabric roof could be removed in seconds for open-air motoring. Side windows were simple sliding plexiglass panels. A basic heating system used engine cooling air, though heating was optimistic in winter. Rain visibility was excellent thanks to the steep windscreen angle, though the single wiper struggled in heavy downpours. But compared to a motorcycle, it was luxury. The KR200's influence extended beyond transportation into popular culture. It appeared in films as the transport of choice for quirky characters. The Beatles were photographed in one during their Hamburg days. It became a symbol of ingenious German engineering, proof that efficiency didn't require sacrifice. Design museums worldwide added them to their collections as examples of form following function. Technical innovations kept coming throughout production. In 1957, Messerschmitt introduced hydraulic brakes, replacing the cable system. The 1958 model received improved door seals and ventilation. By 1960, an electric fuel gauge replaced the reserve tap. Each change was minor, but showed continuous refinement of an already efficient design. Competition emerged, but never truly threatened. The BMW Isetta, with its front-opening door and four-wheel stability, sold better, but consumed more fuel and cost significantly more. The Heinkel cabine copied the bubble canopy concept, but lacked Messerschmitt's aerodynamic refinement. The Zündab put passengers back-to-back, creating a symmetrical design that was clever, but aerodynamically inferior. Production challenges mounted by 1960. The German economy had recovered, fuel was cheaper, and buyers wanted real cars. The special tax advantages for three-wheelers were being phased out. Most critically, Messerschmitt regained permission to build aircraft in 1958. The company's focus shifted back to aerospace, where profits were higher and engineering challenges more exciting. The final KR200s rolled off the Regensburg line in 1964, though Spanish production continued until 1969. The last vehicles featured improved electrics, better seals, and strengthened frames. Messerschmitt offered generous part support, maintaining inventory until the 1980s. Many dealers converted to servicing the growing restoration market. So what was actually the secret to the KR200's remarkable performance? It wasn't one innovation, but the integration of many. The aerodynamics reduced drag to levels that wouldn't be matched for decades. The lightweight construction meant less mass to accelerate and decelerate. The direct drive eliminated power loss through complex transmissions. The narrow frontal area minimized air resistance. Every component was optimized for efficiency, not convention. Consider this context. In 1959, the average American car weighed 4,000 pounds and achieved 12 miles per gallon. It needed 200 horsepower to reach 70 milliliter. The KR200 weighed 1/8 as much, used 1/20th of the power, and achieved the same speed while burning 6 times less fuel. It wasn't magic, it was physics properly applied. The maintenance simplicity was revolutionary. The entire engine could be removed in 30 minutes. The two-stroke required only mixing oil with fuel, no oil changes, no valve adjustments, no cooling system maintenance. The transmission used motorcycle oil changed annually. Tires lasted 30,000 miles due to the light weight. Body panels could be replaced individually without welding. A competent owner could perform all routine maintenance with basic tools. Modern engineers studying the KR200 find lessons still relevant today. The integration of structure and aerodynamics predated computer-aided design by decades. The weight optimization techniques appear in Formula One cars. The direct drive efficiency influenced electric vehicle design. Even the controversial reverse gear solution demonstrated that unconventional thinking could solve complex problems simply. Surviving KR200s have become highly collectible. Pristine examples command prices exceeding $30,000, 15 times their inflation-adjusted original cost. Restoration specialists exist worldwide, reproducing parts with original specifications. Clubs organize rallies where hundreds of bubble cars converge, their two-stroke engines creating a symphony of efficiency. The KR200 proved that transportation didn't require excess. In an era of automotive gigantism, Messerschmitt showed that intelligence could substitute for resources. They took an aircraft company's expertise, a motorcycle's engine, and a designer's vision, creating something that shouldn't have worked but did, brilliantly. Today, as manufacturers chase efficiency through complexity, hybrid systems, exotic materials, electronic controls, the KR200 stands as a reminder that elegance comes from simplicity. Every surface had a purpose, every component justified its weight, every design decision prioritized efficiency. It wasn't trying to be a car, it was trying to be the most efficient enclosed vehicle possible. The environmental impact deserves recognition. Over its production life, KR200s collectively saved an estimated 50 million gallons of fuel compared to conventional cars covering the same miles. The minimal material usage meant less mining, less processing, less waste. The longevity, many still run after 65 years, demonstrates sustainable design before the term existed. Think about what Messerschmitt achieved. They took a company banned from its primary business, engineers trained for warfare, and facilities designed for destruction, transforming them into creators of the most efficient personal transport of their era. They proved that constraints breed creativity, that less can be more, that proper engineering trumps brute force. The KR200 represents a philosophical statement about transportation that resonates today more than ever. It asked fundamental questions. How much car do you really need? How much power is sufficient? How much fuel is acceptable? The answers Messerschmitt provided were radical then and remain relevant now. In our current era of 500 horsepower SUVs and 5,000-pound electric vehicles, the KR200's achievement seems almost impossible. A fabric-roofed three-wheeler with the power of a large motorcycle, reaching highway speeds while achieving better fuel economy than any modern non-hybrid. It wasn't achieved through breakthrough technology, but through the relentless application of aircraft principles to ground transportation. The legacy lives on in unexpected places. The Mercedes-Benz Aerodynamics team keeps a KR200 in their facility as inspiration. Tesla engineers studied its lightweight construction techniques. The Volkswagen XL1, achieving 261 mpg, follows its template of extreme aerodynamics and minimal weight. Every time an engineer questions whether a component is necessary, they're channeling Messerschmitt's philosophy. The Messerschmitt KR200 remains proof that innovation doesn't require unlimited budgets or cutting-edge technology. It requires clear thinking, willing compromise, and the courage to challenge conventions. In 1959, a tiny German company, using aircraft techniques and a two-stroke engine, created something that still amazes engineers today. They showed that with proper design, 36 horsepower, by their optimistic measurement, 10 by everyone else's, was enough to humble cars with 10 times the power. What's the most efficient vehicle you've ever driven? Have you ever seen one of these remarkable machines in person? Let me know in the comments below, and don't forget to subscribe for more stories of engineering brilliance that change transportation forever.